India also, like we are live.
Hi folks, welcome to Geeknight. Uh, so this is the 60th edition of Geeknight CB, and for all the folks who are attending it for the first time, Geeknight Coimbatore is a monthly event to promote the sharing of technical knowledge and increase collaboration among programmers in and around Coimbatore. The event is sponsored by ThoughtWorks. So if you wish to present in Geeknight, please get in touch with any of the panelists today with the topic and title of your presentation. And for today's session, we have Shanmuga Priya with us, and she's going to be talking about hexagonal architecture. So over to you, Shanmuga Priya.
Thanks, Vajaswin. So I'll quickly share my screen. Just put it in slideshow. So welcome once again. Welcome all to today's Geeknight edition. So today we are going to see about hexagonal architecture. So let's begin. So this is the quick agenda of what we will be covering today. First, we'll look at what domain is, and then we will jump into the intent of hexagonal architecture, overview of solid principles, and 3 specific principles of hexagonal architecture. We'll take a deep dive of each principle, and then at the end, we'll have a code walkthrough, and we'll end with the Q&A session. Moving on. Yes, so there is a famous quote about architecture by Robert C. Martin, who is fondly called as Uncle Bob in software industry field. Is a very renowned person in the software architecture. So in one of his blog, I think it's in Screaming Architecture blog, he mentioned this quote. The quote is, "The first concern of the architect is to make sure that the house is usable. It is not to ensure that the house is made of bricks." So what Uncle Bob is trying to emphasize here is, when an architect is building up or like putting up the sketch for the house, right? Very first concern that he would be addressing is that the usability part of the house, right? There will be absolutely, the house will not be useful if everything is proper, perfect, right? But the entrance is like very narrow and a person couldn't enter. It will be of no use, right? And also, like, say that which vendor is supplying the uh, electrical parts of the house or the beautifying part of the the materials that will be used to build the house. Rather than that might not be the primary concern of the architect, right? So the first concern that he would be addressing is that the house should be usable. It should have all the rooms that is required, right? So let's move on. So here is where we will talk about we'll see like what is essential and what is detail, right? So consider there is a house, and for the house, what is most essential part is space, right? Without much space, then there will be no room to live, right? So the space is essential, and there should be all the rooms: the living room, kitchen, and master bedroom, right? So all these things become usability parts. So the usability and space is the most essential part, right? And what building material it is used to build off, whether architect is choosing brick house, or is it going to be Italian marble is going to be there for the flooring. All those things are detail. That is also important, but the thing is like that doesn't comprises the whole domain, right? For the domain, the main centric part or the main thing is space. For the house domain, we can say that space is essential and usability is essential, right? Moving on. So this is the next example. There is a swing here, right? So the domain, if you see that this is a swing, And what is most essential part here is that space to sit. The person should be able to sit here, and the ropes to hold it onto, right? So whenever or when we swing on it, or when people push around, right, they don't fall off, so they can cling on to it. So domain becomes essential and use cases are essential rather than the sophistication or the decoration part. So in the previous slide, this is also this swing which serves the purpose, right? But here this is the crux of it, right? Like swing should be usable. It should have enough space, and it should be having the supporting ropes to hang on to, right? So, but here this is also the swing, but here we can see it is more sophisticated, right? In the sense like it has a cushion seat, like what is the seat made of? This becomes detailed, right? What is the seat made of, or what is the color of the swing? So these things become detailed. So what I'm trying to say here is when we take software, we are humans who build the software for a specific problems, right? So in that we should be focusing on the domains and use cases which are essential part. So we should be, our main concern focus should be on the use case and the domain, and presentation and persistence becomes the detailed part, right? So moving on. So traditionally they were, so why we saw about domain is because of, to talk about this slide. So traditionally we had database centric architecture, right? So where we will have a UI layer, and then inner of it is business logic, and then we have that data access layer, and then we have a database. So when through UI, there will be a request coming through to the business logic layer, and from business layer it goes through data access layer, and which access the database, and again the path follows, right? And the response would be eventually given to UI. So here the dependency is pulled towards database, that is the infrastructure, right? So if there is any change in the database, then it causes the ripple effect in all the environment. It causes the ripple effect in all the layers because of the tight coupling with the infrastructure. Say that today we are using Postgres SQL, right? Postgres database, right? But tomorrow when user decides to move on to a different database, say MongoDB, then what will happen to the business, right? Will the business will still be able to survive? Because it is of database centric, even the change would be because here there is a direct dependency between business and database layer. So if we change the database, then we will end up changing business layer as well, right? So this is the database centric model. This was the like traditional model which has been followed much longer. Now we are slowly moving towards the domain centric model, right? So here domain is the king. Domain sits at the center. So on top of the domain, you can see there is an application and the outer ring, right? Outer ring, you can see presentation. Through presentation, like you may get requests from UI or mobile app or any of the end users interaction path. And then there is a persistence, the database that you want to talk to, and there is an infrastructure concern as well. So here you can see all the arrows point towards the domain, right? There is no dependency for the domain. There is no outward arrow. There is only inward arrow to domain. So this means that domain drives the business, right? All that if we change, so if we apply the same example, if we take the same example that we talked about in database centric to the domain centric, today there is a Postgres SQL here, which is depending on the domain. And tomorrow, if you want to move to MongoDB, then absolutely only this layer will be changed. There will be no dependency, or since there is no coupling here, right? So there will be no change to the domain layer, right? So this is domain centric architecture where domain dictates, or like it gives the on which the other layers are dependent on. So moving on to, so why we are talking about domain centric architecture is Hexagonal architecture is one of the domain-centric architecture. So we're going forward. We'll talk about hexagonal architecture now, which is also known as ports and adapters. Yes, so let's see the intent of hexagonal architecture. So before that, Alistair Cockburn, in one of his paper, he come up with, hexagonal architecture was coined by Alistair Cockburn in the year 2005, which is still now gaining much traction and which is fitting out the use cases to be driven well, right? So let's see why and what is the intent that is promised by hexagonal architecture. It says allow an application to equally be driven by users, programs, automated tests, or batch scripts, and to be developed and tested in isolation from its eventual runtime devices and databases. So what this means is like the first half of it, right? Allow an application to equally be driven by users, programmers, automated test or batch scripts. Okay, be the, whatever the means the input comes from, be it UI, be it mobile app, or a batch script, right? Or it is from cron job, right? Be the input from any of the system, the application should behave in the same way, right? So the application should be like equally be driven by all the input systems or the interactions that comes from the end users. And the application should also be developed and it should be able to tested in isolation. It should be application, the business logic layer or the domain layer, right? It should be able to, we should be able to test that without any dependency of the external systems from its internal, from its runtime devices or infrastructure concerns. We should be able to test the application in isolation. So there are other architectures as well that falls into the similar category, which is onion architecture and streaming architecture. So all these three, hexagonal, onion architecture, and streaming architecture, the basic principle behind this is inversion of control. All these three architectures work based on this particular principle. So just quick intro, like what is onion architecture? It was introduced by Jeffrey Palamo to provide a better way to build applications in perspective of better testability, maintainability, and dependability. And streaming architecture, this is introduced by Uncle Bob. He says that architectures are not about frameworks. Rather, frameworks should be treated as tools and not architectures to be conformed to. It should be based on our use cases. So moving on. So since these architectures are mainly dependent on inversion of control, right? Let's take a closer look of what is inversion of control. Moving on to that. Yeah, this is a quick view of solid principles, right? So solid principles are principles defined for object-oriented design. This is the acronym coined by Robert Martin in one of his design papers long back in 2000, right? So there he mentions like there are 5 principles by which like when we follow these solid principles, we can, the goal of it is to achieve the clean code, which eventually allows us to maintain our code very easily, right? So these are the 5 principles that is defined there. The first one is single responsibility principle, which means that there should only be one reason to change the class, right? So if we have multiple reasons to change the class, then obviously like we need to refactor it because it is not designed in the proper way. Probably like we are taking up multiple things in one place rather than we should be concentrating on one specific thing. So second principle is open close principle. This means that a module should be open for extension but closed for modification. There is this classic example of calculator. Say that calculator has add and subtract button, and tomorrow when the new button, say multiply or divide, is being introduced, right? So what will happen to the module? Do we change the core logic of the module? Then it is not actually, then it is violating open close principle. Actually, the module should have been designed such a way that it should be, it should not allow for any change in the core logic, but rather we can add any sort of, we can rather extend the existing functionality and support the new use cases. Next one is list out substitution principle. That is like in place of wherever that we are using base classes, subclasses can be substituted. Then moving on, there is interface segregation principle. That is like instead of creating one big interface with 20-25 interfaces, there should be, that is of no purpose, right? Like one general purpose interface. Instead of that, like we should aim at creating client specific interfaces, which will actually look at only the client specific use cases. So that is much better. That paves the way for clean code. So the last one is the one that we are interested of, which is inversion of control, that is dependency inversion principle. So this principle states that depend on abstractions, do not depend on concretions, right? So this means that, like, say, for example, there is a high level module, right? For example, this is the UI layer, right? And there is a low level module. So whenever the user request comes, and for example, say this is a database or any infrastructure concern, right? And user wants to pull the data from the database and respond. So if we, here this arrow denotes that high level module is directly dependent on low level. So if there is any change in the low level module, it will be directly affecting the high level module. So the direction of dependency here is top to bottom, right? So how do we inverse this? How do we, sort of flip this arrow? So that is done by introducing interface. So when we introduce an interface between high level and low level, what will happen is high level module will depend on interface. So here you can see this top to bottom, the natural flow, right? Low level module will also depend on interface. Here we can see the arrow is flipped now, right? It is flipped from bottom to top. So the direction of dependency is changed because we have introduced interface. So what will happen is there will be a component or a class in low level module, which will provide a concrete implementation of this interface, right? That is how this flip happens. Let's look at a concrete example of this one. So here, as we mentioned, high level is an application and low level is a database adapter. Direction of dependencies, direct, right? Like high level module is, application is directly depending on database adapter. Say, for example, let's assume it is Postgres database right now. Now, how with the inversion of principle, the next diagram, how it is flipped is, we are introducing an interface, right? So application is the one which will declare this interface, right? And there will be in the infrastructure layer, that is in the database or the low level layer, there will be a concrete class which will implement this interface. So this is, here we can see now the arrow is flipped, right? So this is the inversion of control that is happening here. So the flow will be from, it is not directly dependent, right? It is like from application declares this interface. This also like depends on this interface, and the concrete class, which is defined in the low level, this provides the concrete implementation of this particular interface, right? So that's what is defined here. Interface declared in application layer. All code in application layer depends on this interface. There will be no concrete dependency in application. A concrete adapter of the interface is defined in the infrastructure layer. Both the layers are now depend on the interface. So this is called dependency inversion principle. So if we are clear with this, then hexagonal architecture will be very simple. I will just have a pause here. Is there any questions so far?
Yeah, so far we don't have any questions.
Okay.
Maybe we can.
I'll proceed. Thanks for just I'll just move next. Just give me 1 second. Yes, now we'll see like what are the principles of hexagonal architecture, right? And why it is, or like what are the other beneficial effect here, right? it says like it allows to isolate the core business of an application and automatically test its behavior independent of everything else. So let's see like how the isolation of application, core business of application happens, right? That is happening because of these three principles. And probably like we are able to test the core application without any dependency of the other systems. Probably this is the reason why most of the domain-driven design practitioners also sort of use this particular architecture. So the three principles are, first one is explicitly separate user side, business logic, and server side. Second one is dependencies are going from user side and server side to the business logic. Third one is we isolate the boundaries by using ports and adapters. We'll talk in detail about each principle. Just move on. Yeah, so in this particular architecture, there are three layers, or like three. It is divided into three parts. One is left side is user side. Center one is business logic. The right side, whatever that we are seeing, is server side, right? And left side is what we call as driving side. The other name of left side is driving side. This is what actually drives the business, right? So this might be console application, this might be UI or messaging system as well, right? Which gives a request to business, right? This is what is actually driving the business. So that's why the actors that falls in left side are called primary adapters. Right? And moving on. So in the business logic, we will only have business rules, right? We'll only have business, core of the business problems, or like the concerns of the business problems will be solved here. Well, it will not have any dependency to the outside environment. On the right side, we can see there is a server side. So this is what is required by the business logic. For the business logic to complete, it might need some infrastructure to fulfill that, right? Or as a side effect of running this business logic, we might have to talk to another service, right? Or another system to facilitate it. So that is called, the right side is called driven side. What is driven by the business? Right, so that's why this is called secondary adapters. So after knowing this, we will quickly see the first principle, that is separate user side, business logic, and server side. Right, so user side is what we provide to end user, what he interacts with, right? You can see that user side, the end user interacts, right? The interaction is shown by this particular arrow to the business logic layer. So the user side, like the user can be anybody, right? Like it may not be, it is not only what to say, the system specific, right? Be it the request comes from console application or the REST API or any other system. Business logic doesn't, it's not aware of it. All that it knows is like the intention is being given to it, the notion is being given to business logic, right? It says like, I want this action to be performed, right? That sort of command or notion is delivered to business logic, right? And so the business logic, it will execute the business. So it will have the, it will just have the business vocabulary here, right? Or it can have even domain-driven design. It can follow DDD, which will have all the entities, aggregates, and everything, which is basically used to only concentrate or focus only on the business solution, right? And the next one is like what we depend on the server side, right? So here there are clear segregation of three layers. So why this segregation is important is that, so that we can, when we are working on this user side, we can only be concentrating on the user side, right? We need not think about, we can code user side such that, without thinking about the other layers, right? And similarly, importantly, like when we code business logic, we can only focus on the business rules to be applied, right? Only the solution to be provided for the business. We need not actually think about the complexity of the user side, how the solution will be communicated to the user. That is a detailed part. That's not the essential part. So in business, only essential will be handled. Details are pushed to the sides. Details are pushed to either user side or the infrastructure concern are pushed to the server side, right? So what we just 1 second, people. Sorry for that. So moving on, let's see how this is realized by using a simple example. A small example of an application. So this example, right, this says print poem. So when a user enters print poem, a poem is printed out here. And if he presses any other key, then next poem will be printed. And when the user enters or he types the enter key, then it comes out of the control, right? So that's the use case of the print poem. So let's see the example over here, how this is being realized here, right? So from the user side, you can see here the input or the user interacts with the business by using console. In console, he types the program that needs to be executed, right? So here the user side, the interaction happens using console adapter, right? So the notion of it is delivered to the business logic. So in the business logic layer, business logic is not aware of who sends the request because it doesn't have there is no outward arrow from the business logic to user side, right? So here business logic doesn't know like, who sends the request, but rather it is interested in what is being asked for, right? What it is supposed to do. So coming to the rightmost corner next. So here the poem is sourced from a file, right? The poem is written in a file. So this application, once the user hits out print poem, the application has to talk to a file and it has to read it from the file and return to the user. That's the use case here. So this file adapter, right? So this is the, again, you can see this is the, infrastructure concern, right? Business layer doesn't know where the file is sourced from. Is it from a file? Today it is from a file, but tomorrow we can even change this to a database. Tomorrow we can make this be even real time, right? It can come from Kafka or any other messaging broker as well, right? The system can keep changing here, but business logic will not be affected, right? So what is the notion of this business logic layer is to read the poem, right? Oh, sorry. Yeah, when it gets the request from user side, so all that business logic needs to do is read the poem. So how it is achieved is that business logic introduce, or this particular central layer, it introduces an interface which is called I request versus. This interface is being implemented by the console adapter, that is by the driving side, right? So once the driving side, implements, implement or provides a concrete object of this particular interface type, then business logic knows that it has to read the poem, right? So that is being achieved by using poetry reader file. So what this poetry reader does is it will have an object of type interface, that is I obtain poems. This is again an interface. So you can see there is interface at both the corners, at the left side and the right side. So to the left side, the it is provisioning, or it is allowing the communication to happen from the user side, right? So the right side interface is allowing the communication to the business logic to happen from the server side, right? So poetry library file adapter is the concrete implementation of this particular interface. Right. So
Shanugapriya, before we
yeah.
move on, yeah, there are a couple of questions.
Yeah.
Yeah. So first thing is, yeah, can DDD be compared with hexagonal architecture, or both can be combined?
DDD be compared. Okay. Here actually we are talking. There is one slide. If it is okay, I can just skip to that one. This one. Quick moment. Yeah. You can see here, right? So this is the hexagonal architecture that we are talking now. So the left side, we are saying that left side is about the user side, what drives the business, right? Left side is like the user side adapters, and the right side provides the secondary adapters, infrastructure concerns. So inside the hexagon is the business that we are talking about, right? So the business, you can define it using DDD. Does it answer your question? So this is not one simple hexagon. Inside there are, you can see there are like multiple concentric circles. This at the center sits the core domain. So at the top of it, you can see there is a domain service or domain layer. And again, on top of it, it is binded by application layer. Does it answer?
Yeah, it was asked by one of the attendees in YouTube.
Okay.
Maybe respond there. And we have one more question regarding the Poetry Reader application.
Sure, I'll just move them. Yeah.
Yeah. So I'll just read it out. Doesn't Poetry Reader implement iRequest versus?
No, Poetry Reader doesn't implement iRequest versus, right? Here it is of, it returns, or like rather, this Poetry Reader, right? When it returns to user side, it doesn't return the concrete implementation. Rather, it returns of type iRequest versus. So of interface type.
So does that answer your question?
Does it answer?
Yeah. So he has also put one more comment. So I thought console adapter calls the iRequest versus.
Console adapter calls the iRequest versus. I think I have another slide. I think if we see that, like the confusions will be sorted out. Can we move on after seeing the slide? If it is not clear, can we discuss about this once again?
Sure.
Sure. Thank you. So I'll just quickly complete the principle, and then we'll see the object instantiation orders. Probably that will give us the clear picture. So the sorry, I was about to complete one pointer here. So the purpose of this segregation is that we can separate the the layers or the blocks independently. So the business logic can be tested in isolation, right? And again, the user interaction between the integration between user side and business logic can be tested independent of the server side. We need not worry about the server side when we do this particular testing, right? The same goes here as well. Moving on, dependencies go inside is the second principle. So here there is one more terminology introduced here, that is like, if we think from the arrows perspective, right, the dependencies goes inside to the business, right? So whatever that we are seeing inside this business logic is called inside, and in everything else outside to it, like user side and server side, is called outside, right? So here we can see from the console adapter, the dependency goes inward. Sorry, it goes inside, right? Excuse me. And again, from the server side, we can see a dependency is going inward, right? So there is no outward arrow from business logic, right? So that's how it is decoupled here. Moving on, boundaries are isolated with interfaces. So here around the boundary, we have the interface. So this left side, interface is providing the, for the communication or the interaction with the user side. And again, there is one more interface around the corner, around the right corner, to provide the uh, interaction with the server side, right? So the boundaries actually are isolated with interfaces. So another metaphor here is ports and adapters. So the interfaces that we have seen here, right? This is called ports. And the orange box here, which provides the concrete implementation of the interface, is called adapter, right? So that's why the the alternate name or the main name of hexagonal architecture itself is ports and adapters, but rather like hexagonal, the word seems very catchy, that became very popular, right? The another metaphor or another way of looking into it is all the external dependencies stay outside the hexagon. So if we put the hexagon around it, right, we can see only the business logic is inside and all the external dependencies stay outside, right? And here the another important thing is like port is defined by business, right? So moving on. So here where the dependency, we said that hexagonal architecture is based on inversion of control, right? So here where the dependency inversion is happening is it's actually on the right, because it's very natural for the user side or any input request to talk to business logic, right? So that flow is very natural, or the usual flow. So what is being flipped here is the other end, which is the server side. Usually like business logic in the database centric model in the previous slides, we have seen business logic would have been interacted with server side, right? So that way, like there will be a coupling, right? So whenever there is a change in the server side, it will be an impact to the business layer as well. So now in this case, there is since we have introduced interface here and poetry library adapter, which provides the concrete implementation of this particular interface, the inversion happens here. Moving on. Okay, so this is how the target is reached. So initially when we read the intent, right, it mentions that application can be tested in isolation, right? So how can we test it? As user side, the request can come from a test class as well, right? On the right side as well, server side, we can mock it, right? And independent of both user and server, we can independently test business logic. So the complete focus will be on in the business logic here. Moving on. So this is the slide I talked about. So let's just imagine that there is no Spring Boot framework, right? Usually how we instantiate the objects is like now we use, there will be some of the other dependency framework, right? So see, let's consider that there is no, dependency injection framework, and we have to do it by hand, right? Like we have to manually instantiate every object. So how do we instantiate this? This is how it is explained by even, the author of the blog, I think. So the instantiation actually goes from outside of the adapter, right? So outside of the adapter, I'll just switch here. Yeah, so the outside of the adapter, we have poetry library file adapter, right? So the first instantiation, this object will be instantiated first. So moving on. Right, so it provides new poetry library file adapter. So this may, and you can see that it is returning I obtain poems, right? And the next one is like we are instantiating Hexagon. So this poetry reader injects, or like it takes a parameter of file adapter, right, that we have seen before. And this is of type I request versus, right? And after instantiating the Hexagon, you would instantiate the left side, so which is poetry reader, right? So here the priority reader is of type I request versus. I apologize. I think poetry reader is implementing request versus. Sorry, I gave the wrong information before. So this is how the objects would be instantiated. It would go from the right and then the center and then the left side, leftmost side. And then the leftmost side, user side will be instantiated. Right? The instantiation order is typically from right to left. So moving on. So what are the benefits of this approach, right? So here we can see, application architecture is built on top of a domain model, right? So domain is the main focus here, right? We can concentrate on the business problems. Layers are connected through interfaces. Implementations are provided during runtime. All external dependency like database and service calls are outside of the Hexagon, right? Or which are like outside concerns, like that's not been coupled with the business. So dependencies or couplings are towards the center, which the business drives. All the dependencies are to the domain. Each layer can be tested quickly and independently. Flexible and sustainable and portable architecture. So these are the benefits provided by hexagonal architecture. But if we look at the drawbacks, it initially takes a learning curve to understand what are ports and what are adapters and where do we put this and how do we put the communications, right? So it takes some time to learn that, right, and think in that way. It needs some experience also to do proper splitting of responsibilities between layers and also heavily used interfaces. Moving on. So this is what we have seen before. So when we saw the previous slides, hexagonal architecture, right? It basically talks about three important layers, that is user side, center, the hexagon, and the other ones, server side layer, right? So inside the hexagon, it is not one single part. Here you can follow DDD, right? So this is what we discussed before as well. So core domain sits in the between and which is surrounded by the domain service, right? And which is again wrapped by the application service, which is, there is this outer blue one, which is once again wrapped by frameworks. Moving on. This is another way of, looking into hexagonal architecture. As we mentioned that the green side is the primary or driving adapters. Orange one is the secondary or driven adapters, right? And the left side, you can see there are, from the driving side, there are HTTP, the request comes from CLI, web server, and there can be messaging queue as well. And there can be like, how you want to implement the communication between the layers. It can be either done through command and, there is a famous pattern called command query pattern, right? It can be issued using a command. So when you want to mute it, there is a mutation operation to the domain, then it can go through command. If there is only a query, then it can go through query option. Right. The other option is to use services. So the application services can provide, it can also used by the application services, which would interact with the domain services, right? So this is other way of looking into it. So around the hexagon, around the border, we can see all the ports are, segregated. All the ports are lined up here. And the concrete implementations are outside. So that's pretty much. Any questions so far? Did I answer your questions before? Sorry.
We don't have any new questions.
Okay. So I'll go through code walkthrough. So we can set up the code in different ways, but this is one simpler approach I have seen here. So here you can see the leftmost slide, right? We have the code organized as three main layers or three main folders: application, domain, and infrastructure, right? So when we can see what is there in application. So the application, sorry, in application we have ports defined. So for this particular application, there are two ports. One is HTTP, which is REST API port. Other one is persistence. There is a database port as well. Moving on to the infrastructure, when we expand infrastructure adapter, we can see there is a implementation of the ports. Right, there are two ports and there are two adapters here. One is customer controller and repository. So domain is segregated here in the domain. So you can see in the domain we are following DDD notions, right? So you can put your aggregates, entities, value objects, domain services here. So this is the sample input adapter, that is HTTP. So which is implementing customer REST API port, right? And it has it is auto wired with a customer service, which is the application service. So the input, it is taking the so for this particular domain, there is a new customer. The customer would be registered. So there is a customer service offers a register. So whenever there is a post request for this particular customer, then it calls the customer service to register, right? And for this, but after adding the customer ID will be returned, right? So once we have a customer ID and address needs to be added, then we have a separate API for that. And there is a query API which will return all the customers. Moving on, and this is the sample output adapter or database adapter. So there is an in-memory store. So this particular adapter implements customer repository port. So here we can have the database related methods. So when we wanted to query, we can just query it from the in-memory store and save it to the store and return it. These are the references I've taken for this particular slide. So almost all the slides that you have seen here are mainly taken from the first one, Octo website. Like this blog is actually based on, the first blog is actually based on the conference talk by Alistair Cockburn itself. The poetry verses that we have seen, that example is actually given by Alistair Cockburn itself. Any questions, people?
We don't have any new questions. We could pause here. Yeah, there are no new questions.
Okay. Thank you.
There has been only one question in YouTube.
Okay.
Why the name hexagonal architecture?
Okay. Okay, so let me just go back to one of the slides. Yeah, if you want to picturize or put the components that we have discussed in the previously, right? Adapters, ports, user side, server side, everything. You can draw a hexagon around it, around the business logic, the user side, the center layer that we have seen before, right? That which is business logic. We can put a hexagon. It can be any shape actually. It can be pentagon, it can be a square. But the problem with square is you can have only one adapter, right? But with the hexagon, it gives room to add multiple adapters. So there is, I mean, like, there's no technical reason as such why hexagon. But the main thing is that the shape was natural. I would say it is quite natural when we just visualize it. You can see the ports are on the corner and the shape comes natural. And if you wanted to add more adapters, right, when there are more systems, and this way, like you can add it with much cleaner way. But since ports and adapters are used heavily, its actual name is ports and adapters. But since hexagonal, the name sort of stuck with the people mostly, right? Because it is very catchy. So that has become its name.
Yeah, hope that answers your question. We have one more question. Yeah. So in the code shared, the REST controller was implementing a port, but the controller is actually an adapter which would invoke services calls through port. Is that right?
Yes, my bad that I actually take it from I did not review it before. Yes, you're right. Like, but you can also have an port for the port can be defined for the UI. The port can be defined by the business, right? Excuse me, I just. Sorry, does it answer?
Yep. He has, yeah, he has replied that it answers the question.
Okay, then I will just end the stream.